Hello.
Hello and welcome back to Calculus 2. We are working on trigonometric integrals section 7.3. I need one of those tan 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 or something like that. So I hope you guys reviewed your trig identities because we are going to need those today. I'm going to write few things that you absolutely must know, and then if anything else pops up, and it will, we will fill in the blanks. So here in purple, we are going to start with the trigonometric identities regarding Pythagorean identities, which is sine squared x plus cosine squared x is equal to 1. Now, to get the other two equations, you divide this equation everywhere, say, by cosine squared, giving you tangent squared x plus 1 is equal to secant squared x. Or if you go back to the first equation and divide it everywhere by sine squared x, you will get 1 plus cotangent squared x is equal to cosecant squared x. Now, each one of these can be transformed, so you can write that sine squared x is equal to 1 minus cosine squared can be 1 minus sine squared. So technically each one of these has 3 forms, so it's altogether 9 formulas on the pile. All right? Oh boy, I know. The next pair of equations that you will need to know, even if someone shakes you out of bed at 4:30, you should know the sine squared x power reducing formula, which says what?
1 minus cosine squared.
Yes. That works. And the cosine squared is equal to?
1 plus cosine squared.
Stop stealing her thunder.
I memorized these for the last one.
Awesome. So guys, you absolutely must know these formulas, otherwise there is doom, impending doom.
And just a bit confused how, or is the sine squared x equals 1 minus cosine squared x? Do you get that from sine squared x plus cosine squared x equals 1? Or?
This one?
Yeah.
The way you derive this is from the fact that cosine 2x is equal to cosine squared x minus sine squared x. We also can write it as right, and then you can just work out, substitute here from there, and one of the forms. It's very easy to derive both of those formulas from there, and then you can flip these formulas here to obtain the square root formulas as well. All right, great. So we have that. Now, the next part is to review all of the derivatives and all of the integrals for the vanilla states, what we call them, which is the derivative of sine x is? That was fast. And the derivative of cosine x is? Negative sine x. Good. And now the derivative of tangent x is? Secant squared x. Very good. And the derivative of cotangent x is? Negative cosecant squared. Very good. And then the derivative of secant x is? That's the secant x tangent x. Very good. And then the last one is the derivative of cosecant x is? Negative cosecant x cotangent x. You got to know them all. Now, it's not difficult to actually Memorize them because look at the symmetry. Do you see that every single derivative of a co function is negative? What do we have? Cosine and cotangent and a cosecant, right? So if it starts with a cof, it's negative, right? And if it doesn't start with a cof, it's positive. Also observe the trigonometric pairing, right, for this. Sine is always with cosine. Tangent is always with secant. They don't have exceptions to that. If there is sine, there is cosine. If there is cosine, there is sine. They're together, right? Tangent, secant, 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 tangent. You see that? And then you have the cotangent, cosecant, and cosecant, cosecant, cotangent. There is no, on this list, there are no exceptions to that rule. Now observe the pairing, sine and cosine, tangent, cotangent, secant squared, cosecant squared. There is a lot of symmetries here that you can exploit, and technically you are remembering formulas 1, 3, and 5. You're remembering formulas 1, 3, and 5, and the formulas 2, 4, and 6 are the repeats in the other, right? Do we all see that? They're negative. Great. Now, integrals are going to be read backwards. So what's the integral of cosine? Positive sine. What's the integral of sine? Negative cosine. So this minus sign is going to migrate on the other side, and you will just write the integration formulas. And all of these will be used in the next two sections. We'll try to take care of both of those tonight. So now, to figure out the integral of cosine x, guys, I'm still in Calc 1. This is equal to sine x, and then you have the plus c. So it's plus c or minus 1. That, you know, depends on you. Derivative of sine x dx, the hell? Sine x dx is negative cosine x plus c. Integral of, there's a spaz over here. Does anyone have an Apple product so I can break it? Secant squared x, just anger, equals to, don't worry about it, tangent x plus c. The integral of cosecant squared x dx is going to be negative cotangent x plus c. The integral of secant x tangent x dx is going to be secant x plus c. And we have one more, integral of cosecant x cotangent x dx is equal to negative cosecant x plus c. So this is all we have from Calculus 1, and look how perfectly that fits actually on the page. So you are supposed to know these 12 things, plus those 5 above is 17 things. So when someone tells you, what do you know? Well, I know these 17 things, which you can use to get more stuff. Here in blood, pairs, sine with cosine, secant with tangent, cosecant with cotangent. I can't stress enough that you need to recognize these pairs right away, because if it's not paired, it can't be done using Calculus 2. Chapter 7. All right? So your problem must have this. Now let's say you have a cotangent and you have secant. Is it all lost? The answer is no, because both cotangent and the cosecant have common ground in sine and cosine. Cotangent is cosine over sine, right? So you might be able to use some kind of u sub and so on when you change all of these functions back into sines and cosines. So if you have trouble with trig identities, please take care of that part where you know that tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, and cosecant is 1 over sine. X to be able to do these conversions on a regular basis if you don't have pairing. This section now is not about learning a new method. What we are going to use is a marriage of trig, identities, and u sub for the most part. We will be using also integration by parts here and there, but I would say 97.8% of the time you will be using u sub for these integrals. And next section, trig substitution, is application of all of this stuff, which will also fall back to u sub and mainly use u sub. So now let's take care of this. We are ready to start the Calc2 lecture. So sine cosine pair. We have, you know how hell has levels? You never want to start there, right? Well, this is also, I would like to say that there will be 3 levels in this case. We're going to have, you know, vanilla level, and then manageable, and then hell, right? So let's start with simple problems that you actually already seen in your Calculus 1 course. So I actually expect that every student in this classroom is able to solve a problem like this, right out of the box. Because you should be able to see immediately that this is a basic u sub problem from Calc 1 that you hopefully covered in your 5-5. Right, with the instructor, whoever taught that class. You have u, and the derivative of that is du. So technically, some of you are already able to just look at this problem and say, oh yeah, the answer for this is sine to the 9 divided by 9 plus z, and just walk away. Because the whole thing here turns into u to the 8. Which is u to the 9 over 9, right, Rana? Right?
Yeah.
Oh, of course. And that takes care of this problem. So this is that stuff that you are already carrying on from your Calc 1 class. So u is equal to sine x, which means that du is cosine x dx. And I'm going to underline red. Here is your du, exactly the same. So now what we have integral u to the 8 du, which is u to the 9 over 9 plus c, which is 1 over 9 sine to the 9 x plus c. And that would be the end of that problem. So the exponent over here, it doesn't matter. You can put 107, which is going to be 108 over 108, and you're done, right? So in that respect, not a problem at all. Here is another for you. So how about cosine to, what's good? Is 93 good number? X times sine x dx. So do this one on your own. I'll give you like 17 seconds, no pressure. Yeah.
I literally searched it on Google. I was like, what is E? It's so 40 on the set, and it said like.
You probably got
that, no, it said that you get a bad grade on this, and you like this is it.
And then we'll have to wonder why. Now that's so bad. Good thing we're going to have. Like 44. What can I do? Now the new one must have.
That's a bragger.
It's a good time.
Oh yeah, 93.
I'll loan you 5 of my points when you just grade 15%. For the next
What $1 million? I don't get it's better than
Okay, this is way too much time. I just got to chat a lot. So u equals cosine x this time. Du will be negative sine x dx, but I do not have that negative. So I'm going to fix that by installing 2 negative signs there. And the whole integral becomes negative integral of u to 93 du, which is negative u to 94 over 94 plus c. And then we finally, right, I don't care about u, care about the x. So what we do is we put negative 1 over 94 cosine to the 94th power x plus c, and we walk away. So we're done with Calculus 1 portion. Now we're going to crank the heat a little bit. So the next step up here, the next level, right? So it's going to look like this. You're going to have, let's say you have sine to, I don't know, sine 8x, and that's multiplied by cosine cubed x dx. So now you have 3 cosines. All right? You have 8 sines and 3 cosines. This is the problem where you will have to think how to solve it. We know that the derivative of sine is cosine, derivative of cosine is negative sine, and we know that we have to keep one of those aside to have it as a building block for our du part. Observe that there are 2 previous examples that every time you found du, there was either cosine or sine attached to dx, right? So now, if I am to use the same logic here, if I set my u to be sine, then I'll need to save 1 cosine for dx. And if I set my u to be cosine, I'll have to save a sine for dx. Now looking at this example, I see that I have even number of sines and odd number of cosines. So which one of these would yield a single sine or single cosine with ability for the leftover to be transformed? What does that even mean? Cosine. You see, if I peel off, and that's the technical word, okay? If I peel off one of the cosines and save it, save that for du, what's left behind is cosine squared. And what can I do with cosine squared? What can I do with cosine squared? I can, no, that will make it worse. 1 minus sine squared. So I can transform that cosine squared into 1 minus sine squared. So it will be sine to the 8x times 1 minus sine squared. This is your Pythagorean identity, guys. And you have now the entire problem in terms of sines, and then there is your cosine that we saved for du. So now when I look at this, I have sine 8x minus sine 10x when I distribute, cosine x dx. And if you really want me to write everything out, I will write two integrals here, sine 8x cosine x dx minus the integral of sine 10x cosine x dx, and then u equals sine x du equal cosine x dx, which is the substitution that works for both of these. These problems are long to write out, but, you know, and I have no doubt that some of you can just look at the problem at the top and just write the answer. That's fine. For these problems, we'll open the gates of hell soon. Don't panic, all right? So what's the final answer? It's 1 over 9 sine to the 9x minus 1 over 11 sine to 11x plus c. Wonderful answer. And this is that second level of on the ladder. So the first one is you can use u sub right out of the box and you're done. The second level is, well, you will have to, you know, massage the expressions a little bit with these trig identities, and those trig identities are Pythagorean identity, right? So it's you figuring out which one has the odd number. One year, I thought it would be a good idea to kind of check if you grasp that concept, so I put the following example on a test, and it was a massacre. So here's that problem now, so we don't have to, you know, see it again for the first time on the test, right? So integral of sine cubed x times cosine to the fourth x dx. Okay. What do we do here? Yes? Yeah, we peel the sine. That's what the odd number is. Now, what would you do if they were both odd? Pick one of them. Pick any. It doesn't matter which one you pick if they're both odd. Now, remember that I told you there's a third level of hell here? Yeah. That's when both are even. Those are the evil ones, okay? As long as you have one odd or both odd, these problems are a joke. When you have both even, it's going to be what? All right, so just do this quickly, and then we're going to look at both even. That's next. I have to say that'd be a hoot and a half. It is. So we have, in this case, guys, we locate the odd exponent, we peel that one, transform the others, right? And then just go and solve the problem. So yeah, that's it. I can't. Yeah. Exactly. And two more until you find the point of comparison. You guys got this. The next step. I mean, what happened? Did I get it? What you should do is you can take the derivative and see if it works.
George, do you want to take the derivative?
Or did you get the same thing?
No.
It's either. Oh no, he didn't solve it yet. That's why here's the
No. Okay. I got it first.
Done? Sure. Check. All right, cool. Right now, you go back to your. What is it?
I mean, pasta is kind of noodle. It's spiral.
It's wonderful and cold.
I mean,
I don't think I would touch it with these.
I'm mostly eating it because I just like too much food, and this is what I have. So.
But there's a microwave right there.
But are you? Are you really gonna hold the class?
No, you can eat it. By the time I solve the problem,
It's good if you need the calories, which I do. Or not calories, but if you.
All right, let's take a look at this problem together. So, since sine has the odd, I don't care what's showing up first, what's showing up second. It's multiplication. You can swap the order. That's okay. So, I'm going to peel off one sine. So, sine squared is left behind. And cosine to the fourth, and then sine x dx. This one is then transformed into 1 minus cosine squared x. So we get integral of, open parenthesis, cosine to the fourth x minus cosine to the sixth x sine x dx. U equal cosine x, du equal negative sine x dx. It's kind of difficult to do this class in a, the market with all of the,
Do we have to put the, divide by 1 minus cosine?
That's not divided. That's me saying this is the.
Oh.
That's not divided. It's it's a trans. Yeah. Thank you for actually noticing that. It's not a division. All right. So what do I need? I need a minus on the first one. So that's going to be negative u, and then to the fourth plus u to the sixth du, which is negative 1/5 u to the 5 plus 1 over 7 u to the 7 plus c. And then we use negative 1/5 cosine 5x plus 1 over 7 cosine 7x plus c. Yes?
I'm just confused on what we do if it's like sine 5x cosine 4x.
You pull one sine, right? And then you can transform those 4 sines that are left.
Oh, into 2 sine.
Yes.
Okay.
So if you are transforming, okay, so let me do that in pink because it's not calc. So transformation, there we go, transf. If I have to go and change sine to the 4x into cosines, I will write sine squared x everything squared, which is 1 minus cosine squared x everything squared, which is 1 minus 2 cosine squared x plus cosine fourth x, right? Just like a polynomial. You do the foiling. Great question. Excellent. I'll keep in mind for the test. Are you ready for 2 even? Yes.
So the number will never be above 3 or 4.
Why not? Wow, that was the plug of the century right there. Yes. 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 The number can be 12. It's okay. If you know Pascal's triangle, you can foil anything like this.
God.
Yes?
I need to stop saying that in this class. No, but well, which thing was Pascal's triangle? I remember.
Pascal's triangle for foiling?
Yeah.
So how much is x plus 3 to the fourth power? Just write it out. No. They're just a foiling.
Oh.
So you can have cosine, sines, you can have anything. So you draw a Pascal's triangle. And this is your fourth exponent. So these are the coefficients. So you just write it as 1 times x to the fourth plus, and now you have 4, that's the next coefficient, 4 times x to the third power and times 3 to the first power, so just times 3, plus the next coefficient is 6, x goes down, the other power goes up, plus, then the next one is 4, and then you have x going down, 3 going up, and then the last one is plus 1 times, the coefficient is 1, 3 to the fourth. And you just FOIL it out. So you don't actually have to go, x plus 3 times x plus 3 times x plus 3 times x plus 3. You can just work it out this way. Now, whether there are cosines or sines inside or e to the x, it doesn't matter. Just grind it through. You have the coefficients, and the first exponent goes down from the largest one. And so you see that x exponents goes 4, 3, 2, 1, and then nothing, which is 0. And from the back, 4, 3, 2, 1, and then nothing, which is 0. So you can foil with this anything you want.
Where did you do this?
Oh, you learn it just online because it's fun. It's not in any of the courses. This is just fun stuff.
It was in our pre-calc.
It was? Nice.
Yeah.
No, pre-calc honors.
Honestly, that's what pre-calc.
All right. Where's Dal?
I don't use or I don't remember. It's just
Well, we are going to do even now. Well, tough luck.
some sort of triangle.
Ready? Integral of sine squared x cosine squared x dx. Like the easiest one I can come up with. Yes. I could, but the problem is that I don't have the other function to do the u sub then. Because if I write either, let's say you write cosine is 1 minus sine. You will be stuck with sine squared minus cosine, sine squared minus sine to the fourth, without any cosines around for du. Yes?
Would the power reducing formula do anything?
Ryan, what do you think?
I was just about to ask that.
Exactly. Very good. So power reducing. There we go. Write the power reducing formulas, FOIL them, and see what you get. Power reducing formulas must be known in this class, otherwise doom with 4 O's.
So we're doing the both of them?
Yep. Oops. So there is a quarter that you kick out eventually. And then you FOIL these puppies. Now this is the difference of squares. Oh my goodness. Isn't it awesome? Look at that. We got cosine squared again. Now what?
You do it again?
Power reduce again, exactly. That's how we do it. It's a party. Now hopefully you're doubling the angle, otherwise it's not going to be pretty.
Wait, where's the 2 go? Oh, I got it.
You see the 2's?
Yeah, I see the 24.
I do not have to zoom in, right? Okay. Yes.
Could you?
Wait, doubling the angle because square, right?
The formula for power reducing always doubles the angle. So we used to have a single angle over here. It came and went into 2 times. Now the other time around, it was 2x, becomes 4x. It always doubles the angle.
So what happens? Oh, wait, no.
All right, so now we're going to work this out. Don't forget these parentheses, they're important for notation, right? And then 1 minus a half is a half. Kick 1/2 out. No coughing. There's a lot of magic happening here. Excellent. Time to integrate. Aren't you happy? Of course you're happy. We don't have to use any, it's just vanilla integration, right? So what's the integral of 1? X. And what's the integral of cosine? Sine. So sine 4x over 4 plus c. When I factor out 1/2. Because the 1/4 changed into 1/8. Look. So I did factor 1/2. 1/2 times a quarter is 1/8, which is what is circled there. And we just, now do you have to do all of these things? The answer is no. You can just, you can just integrate here if you want to. But I don't know, I like to simplify, not drag like 5,000 fractions if I don't have to.
Why did you wait to pull the half out? Why did you do the whole one trick thing? If you were still going to pull the half out? Well, that was just to get the half by itself and then pull it out.
Well, if you look at all of the rows right here, right, I have only that part of the problem under a half. So I give each one 1 and the cosine gets their own half. So you see this half belongs to 1 and belongs to cosine. So each one got their half. That one is that one, right? And then when you subtract 1 minus a half, you get a half. And this half is the surviving half that was, yeah. And then you pull a half out.
Then why does it become 1 again?
When you factor out a half divided by half, right? Because see the quarter became 1/8. I factored out a half from both. Half times a quarter is 8. Yeah.
And then you would accept that as the final answer then?
This is the answer. Done deal. Right here. I have a problem for you to practice, and then we are done with sines and cosines. We are going to go and work on secant tangent pair. I know, it's very exciting. Today is a really, it's a beautiful day. It's Tuesday. This could be considered like a standard final exam question, all right? If there is to be a purely trig integral from 7.3, like this would be the cool one to put. So let's see, how would you deal with this? Obviously, hopefully, we'll talk to people, around you to get ideas and share ideas.
That's what I said before. That's what I said. I don't know when you do it.
Because Pythagorean.
Oh, wait, no, no.
That would be global flat. No, no.
So then you
Oh, they're gonna use that against your point. You put it in your nose, you can't say that. No, I'm not either. I'm in the fire department in my town, so I got brushed by this morning. So I was walking through the woods and I ate shit. You know, there's like this bigger, but there's almost like
So you didn't have any
who knows that on the side just like just sticker shit all kinds of stuff.
that you could run on your what now? Because what I'm worried about is how many times we have to do that until it's
Enough times.
That's the
are we on the right track?
yeah.
Okay. So you have to do it enough times.
So I think Tyler's right.
So we can
Awesome.
I think, oh, I can.
What? No.
There you go. There's your answer.
Be famous on 4 points.
Yeah. Yeah. That's it's 7.
See how they
There you go. Can you use pencil, maybe?
Did you even weekends roll out?
Yeah, you can. I don't understand. Okay, you know what I can understand? I can like use it really use or use like an erase tool pen for this.
I see it.
I'm dying.
You know what this drawing is good for? Cartoon tunnel. It's a lot of writing here. They're awesome for us.
Well, what's cool about
This and the next
like
section.
the new ones, like his,
Who homework
he
assignment?
doesn't even have
Carpool
an eraser.
tunnel.
Each one will be pure friction.
I mean, you don't have carpal tunnel. I know you haven't done any work.
I think it's like some sort of like composite rubber or something that like doesn't wear down. I mean, I'm sure it's like using it, but I'm just wondering. Wait, do you has it worn down? But still. Oh yeah. Those refills? Oh, most pens do. Yeah. Well, I have. I use these G2 pens, and they write really well. And I use $5 each. Uniball is good. These are like $5 each. One of these from Walmart, a pack of 2 refills, is like $1. I've also got myself a nice Uniball Signal.
And there you go, done. 5 seconds.
Wait. Oh.
So, as you're looking at this problem, you see that you have an even exponent. What would you do if this was 5? You would peel one cosine off, right, on a side. If it was 5, you would peel one cosine off, and then they take the remaining 4 cosines, turn them into sines, and use u sub, right? So if it's odd power, it's always the same procedure. Peel off 1, and then make sure that everything else is on a pile of the other, right, either sine or cosine. But now when you have even, I know that 4th power is the square of a square, because 2 times 2 is 4. This could have been 6th, right? It would be a different situation. So now, when I have a square of a square, I deal with the inside square, the power reducing. I still have the outside square. Then the outside square squaring 2 gives me a quarter outside. And the square of this is, again, square of binomial. So square the first, then 2ab, the middle term, and then plus b squared. Now, if you forgot the middle term, please facepalm yourself right now, because that's where the grades go down. Once I have the expansion here, I notice that I still have a square on cosine, so power reduce again, because I have to. Every time you have an even power, hey, top block, what are you going to do? Power reduce. Now, look at this. You have a 1, and then a 1/2. 1 plus 1/2 is 3/2. Copy this one, and you have 1/2 over here for this cosine. So this half over here belongs to 1 and cosine. So 1/2 plus 1 is 3/2, and then the 1/2 stays for the cosine as well. It's like that half distributes over both. And then now it's all single cosines. So just integrate, right? 3/2 integral x right there. And then we have cosine is integral is sine, but because of this 2, it will sine over 2. And then that 2 kills this one. And then over here, 1/2 survives. You have sine over 4. Well, 2 times 4 is 8. Now, some of you might still be shaky on that shortcut formula for quick integration, so you don't have to go through 17 u subs. You might want to... I know. Yeah, I teach a lot of students in this school, and they're all happy to have me, as you can see. So, no, I'm still here sitting there. So here is the formula. Let's say integral of cosine ax dx. So you have some number in front, whether it's 3 or 4 or 17, whatever it is. It's going to be sine ax over a plus c. And the sign does the same thing, right? Negative cosine. So that's what I'm getting. So see, this cosine here goes into sine over 2, and that over 2 kills the 2 in front. This one, cosine 4, is going to be sine over 4. 4 times 2 is 8.
Yeah, before I was like,
The top.
no. Could you copy the problem?
Which one?
The one that's good.
Last problem we did? Okay. Not a problem. All you need to do is just tell me exactly what you need. I am a very accommodating person that has your best interest in mind. The next part of this lecture is tangent secant part. So now you can make a little mini title, right? Tangent secant pair. Whatever we learn for secant tangent pair will be mirrored for cosecant cotangent pair with the minus signs floating around. So there is no reason to go through cosecant, cotangent in great detail, because all you need to know is there is a minus sign and they work exactly the same as these guys.
Oh, thank you.
You are very well.
Can you explain that formula one more time?
Which formula?
The cosine A what?
When you have a number, so that's when you're integrating something like this. You see how it's 4x there? So that would be technically over 4 over here, but that over 4 multiplied the over 2 and then became over 8.
Okay.
So that's that 4 at work. Next part is secant tangent pair. And to solve these problems, we have to observe how pairing works. So we know that the derivative, I have this written up there, but the derivative of tangent x is secant squared x. And we know that the derivative of secant x is secant x tangent x. So what are the functions that I have to leave behind for du part? Well, it's either secant squared or secant tangent. So what I like to do usually is I like to hit the vertical line over here and say u du. So if I have tangent to the 6, I have to peel off 2 tangents and transform those into secant squared so I can have enough for du part, right? I think. I hope. So let me just get to certain examples, because if I start making these up, we might end into trouble, with big trouble. So let's take a look at some vanilla examples that can be done right out of the box without too much thinking. For instance, integral secant to, 17th power x tangent x dx. So how do you do this? We use u equals secant, yes. But you see that for du, so if you use u equals secant x, du part is going to have secant x tangent x dx. So you see that you still have to peel one secant off to have it for du. Do we all see that? So sure, we are going to have u equals secant x, and I have 17 secants there. But when I do the du part, there is one secant that we need for du. So guys, this is the game of actually making sure that you are saving what you are going to need for du on a pile, and then dealing with everything else that it's a leftover. As a student, I won't lie, this was a little bit tricky for me, this part here with secants and tangents. So I was actually writing both substitutions and then see which one it fits, because I'm visual. So I would write u equals secant x and u equals tangent x, and then calculate du for both and see which one would algebraically fit better. You see that, if you said that this one to be, right, tangent to be u in this case, clearly, you have 17 secants, not 2 for du. So that's a little bit challenging to work with. So we have to peel one secant, and I'll underline it in blue, so we see that now du parts are the same. So this was one of those easy problems in this case. This is u to 16 du, which is 1 over 17 u to 17 plus c, which gives us as the final answer 1 over the 17 secant 17x plus c. It's either plus c or minus 1, you know that by now. Next step. I know you're waiting and you love it. Integral secant to the 8x tangent cube x dx. So this would be the next level. That's an 8, yes. You know, honest, you can put any exponent there. Like, what would you like it to be? You don't want tangent square there. That's I'm telling you that right now. But yeah, this is gonna be fine.
Look how power reducing we can do for these is there.
Yeah, but no. That's the best answer I can give you. All right, let's take a look at this problem. So, what do you think we should do here? Shh, guys. Yes?
First do tangent squared x and tangent x, the tangent like spread out the tangent, and then
Okay.
spread out the secant also.
So you want to steal one secant and one tangent and put them aside for du. All right. So we can do that. Awesome. So I'm going to steal one secant and steal one tangent and have secant x, tangent x, dx, in store for du. And then do this, yes. Pythagorean identity to change these into secants.
Secant squared theta, secant squared x minus 1.
So secant squared minus 1, yes. So that will be secant squared x minus 1. Now we distribute and then walk in the park after that. So secant to the 9x minus secant 7x times secant x tangent x dx. And then we have our u secant x and then du secant x tangent x dx. And that gives us integral u to the 9 minus u to the 7 du. It's a lot of practice to do this, guys. A lot of practice. But hey, now you're 1%. So you gotta work and act as 1%. Right? With great power comes with great responsibility. And 4 of you know what I'm talking about. Now everyone knows what I'm talking about. You notice how answer is not 8 or 9 or pi or 3 anymore? Now it's... can we have this as definite integrals? Yeah, you have the limits and then you plug the limits. Boy, oh boy. So what's secant of 45 degrees? Right, pi over 4. And then raise that to the 10. Yes.
So when we can play this like NJIT that don't let us have calculators, how are we supposed to solve this section of images?
Like this. Without calculator.
Well, do they make it so then, like, I don't know, like, the exam won't have, no, they could have, because then...
Yeah, exactly. Very good. See, you answering your own questions.
No, I'm saying, like, I was thinking, like, maybe they just don't put secant.
My brother is like
Definitely.
final year right now, and he uses a graphing calculator.
Not in math classes.
Oh, probably.
Yeah, there we go. You can use graphing calculator in other classes, but
Yeah, like-
math department here, Rutgers, Orange, they don't allow. Virginia Tech, yeah. You just leave it at 58.
So it would just be like incomplete answers.
You could, like, write it out as, like, I don't know,
All right,
secant 10x.
ready for the next one?
Secant 10x.
Let's see how wonderful these problems can get. How about integral of tangent to the 4th? Do what? I wouldn't be particularly proud of myself to use this problem. The next one, definitely. So what do you reckon we should do here?
Split it.
You have 4 of them in the denominator.
square over it, so you can pull one of them. What's that?
That's the one.
So yeah, you will be splitting this tangent square, but then what do you do? How are you doing?
Well, if you want to do secant square, then back. But you're all right. I don't want to be on the wall. So we don't use secant square.
Yeah. You got some more.
Oh my god.
There's no other idea.
Oh.
Clearly there.
All right. So see, this is one of the tricky ones, right?
Oh, I think I
And you know.
I think you should do one of them. Do one of them because D you have to be secant squared x so that you can make the tangent u, and here D you have to be.
Boss right there. Boss right there. Should you? How about you try that on the board? I'll be here.
And drop the marker.
I don't want to.
Why not? So yes, she figured it out. You are supposed to break it up into tangent and tangent squared. And once you break it into tangent squared, you are supposed to change one of them and leave the other. And then from that point on, work. Work on that and I'll
Leave one of them high.
yeah.
Okay, so now you will distribute.
Yes, that's the one.
Oh.
Okay.
Secant squared x minus tangent squared x. Yeah, you need parentheses around everything. Right there and the end, yes, because it's times ds, right?
Okay.
You can go on then up.
Hold on, I got to this part. I just got to that.
Okay, so you have to leave your paper there and you can keep reading.
Well, your dx has to be secant squared x. So, well, can you do this that? Cancel it. No, baby, that cancel. But why? They're both tangent squared. Oh, I see. So my those close there. Okay. Well, factor out the
I have to
tangent.
write it all over again because it's.
Can I factor out the tangent?
So write it again.
Okay. Okay.
Leave the papers over there.
Okay, I know. Okay.
If you write u equals tangent,
Yeah.
or if you create this tangent, x du dx.
All right, guys, look at this. So we have now at the end tangent squared, secant squared. You all have that, right? Yeah. Now look at your u. U is tangent x, and you have secant squared for du. So the first integral is u sub, and it's easy. How about the second one? The tangent squared only.
Two integrals, so tangent squared.
Two separate integrals, yes. So what is the second integral?
And then you gotta do the.
So should we do it again?
Yeah.
Same time, guys, right? Same time?
This one you already do
U squared du. No, just do u squared du. And then minus. Now what are we going to do for integral of tangent squared? Just write it down. What are we going to do for that? I'm asking everyone. Yes.
Same. Secant is 1 over cosine. Wait.
You just use the. Is that all you
Can you accept?
You hear that? You hear that? Yes. Yes.
Secant square minus 1.
Secant square minus 1. And then the integral of secant square is? Tangent, right? See, this is a tricky problem. So the second integral now is going to be secant squared minus 1 in the integral.
Okay, hold on. I'm just gonna, I gotta mark right here. So this is gonna be U3 over.
You don't need integral now.
You don't want me to.
No, just do U3, yeah, but no integral. U3 over 3, good. Minus, open integral now, again, integral. And you have secant squared minus 1. dx, in parentheses, everything. And now, the integral of secant squared is tangent, and the integral of negative 1 is positive x, right? You see the two integrals here, right?
Yeah.
Secant squared, that's tangent, and then minus and minus is plus, so that's plus 1 the integral is x.
Oh, so this is x, and then you.
I will.
3 minus x.
No, wait, where's your tangent x? Minus tangent x first?
Minus tangent x.
Plus x.
Plus x.
Plus c. And then you have to do u. What's u?
U is.
Well, that's fine. You don't have to. U is tangent x. That's fine. I'll be writing.
I'm just gonna slow down your.
You know what's going on? Yeah.
Now you're gonna explain everything to everybody?
You want me to explain?
Yeah, you can. Sure. All right. Let's see the explanation for the problem. The whole problem.
Does that say minus 10x plus x?
Minus 10x plus x plus 3.
There's a trick for this? Yeah.
And that's the
So I'm going to redo the whole problem. Just try to, take it all in, and I'll erase it, and then I'll write it on a tablet, so it's there. But that's it. So what? They take, 2 students or 3 students to do this? You do tests individually, right? But it's okay. You guys learning. This is the power of group work, right? You learn in groups. That's why you have lab groups and so on. Yes.
Since you how you got secant squared x minus 1, like, I know you said that if u is.
From here to here.
Yeah, just like.
Well, u cubed over 3, u cubed over 3, right? But then you have the integral of secant squared is tangent. That's the basic integral from Calc 1, right? That's the Calc 1 integral. And then negative 1 is plus 1, integral of 1 is x. All right, so let me, I'm going to erase it, and I'm going to write it again, but you want a picture with it?
No.
I'll take it with your phone. You can post on social media. You stand like this. No?
Okay, just take up 10
What happened? We won't have time for that. We have, is that the correct time up there? Yeah. All right, guys, this is it. So let's quickly recap this problem and go next one. So this is going to be broken over 2 tangent squares first. And we are going to switch one of them into secant. So it's going to be tangent squared x, and then we have secant squared x minus 1 dx, and then we will distribute to create 2 separate integrals. So we have tangent squared x, secant squared x dx, and I'll put minus another integral for tangent squared x dx. Now, as you can see, this integral tangent to the 4x teaches you actually how to do tangent squared as well, right? Because it's now its own separate integral that you have to figure out. So for the first one, we are going to use u is tangent x du is equal to secant squared x dx. So the whole integral becomes u cubed du. Minus, and for the second integral, tangent, we will have to write it as the secant squared x minus 1 dx. Yes?
U squared.
That's what I said. Please pay attention. Right there. Squared. So now that we established that that's a square, we integrate the first one to get u cubed over 3 minus, and what you have here is a vanilla integral. This is Calc 1. You need to know that secant squared, integral of secant squared is tangent, because the derivative of tangent is secant squared. So we have minus tangent x, and then you have two minus signs. There is a minus here and a minus here, so that gives you plus 1. Integral of plus 1 is plus x, plus c, and you will plug in your substitution tangent, so that's 1/3 tangent cubed x minus tangent x plus single x plus c, and that's the answer. Now, if you pay attention, right, carefully, you see this portion of the problem. That's a standalone tangent square problem, actually, right? You see that? So that's a standalone tangent problem, tangent squared. So now with this one problem, you learned how to do tangent squared and tangent to the fourth. The next question is, we said that the integral of secant squared is tangent. What is the integral of tangent? X dx. Like, we know how to do tangent to the fourth, we just did that, and tangent squared was within it, so we know that as well now. But what's tangent? Yeah.
What?
Natural log of secant x plus c. The hell we get that now? No, he knows it. No, he doesn't have a cheat sheet. He knows things. Follow his example. How do we get that? Yeah. Yes.
Oh, wait. Is it because, like, tangent x is equal to sine x over cosine x?
And then use what?
I don't know. I'm spitballing it now. No, use their identities, I guess.
Use
Yeah, that's it.
what's u? Sine or cosine? Cosine. You can't have your du piece in denominator, so it has to be cosine x. And what's du? Minus sine x dx. Do I have a minus? No. Boom. Here you go. Minus. So now it's minus integral of du over u, which is? There it is, right? ln absolute u plus c, which gives you ln, negative ln, of integral of cosine x. Sacrilege. We started the problem with tangent and we are ending with the cosine. Not cool. We know that the pairing must be tangent secant. But then there is this minus in front. And we just say, whew, because that minus will travel as a -1 exponent, which will flip is 1 over cosine and becomes a secant. And we are saved. And our life is beautiful. That minus will say that this is a cosine x to the -1, not an inverse. That's why I didn't put cosine minus 1, not an inverse. This is a -1 exponent, which will make it a 1 over cosine x, which is ln of secant. Did you read the title? What the hell? No, it's not. So now you know what the integral of tangent is. You can find the integral of cosecant, you can find the integral of cotangent. Actually, good luck with the integral of cosecant and secant on their own. They are very interesting creatures. There is actually a trick that you have to use to find those, and I will let you discover those in either textbook somewhere, or maybe YouTube or somewhere, if you're interested in those kind of things. I will promise one thing, and that is that I will stay away from secant cube problems. Now, those of you interested why, please look it up. Secant cube. The solution and the calculations and all of that. Guys, this concludes trig. Now, what I'm going to say about your the other pair, right? The other pair, cotangent, cosecant pair, same as tangent, right? You're playing the same game. Do I leave cosecant squared on the side, or do I leave cosecant cotangent on the side? And you just have minus signs floating around. That's all. So cosecant, cotangent pair, same as secant tangent pair. You found it? And it's beautiful, right? 13 steps and becomes something around.
So like, it looks nice at first, but then it gets a little. I found it in 12. So.
Ooh, you beat it by a step.
It probably combined one of them. I mean, yes.
So when you say that the cotangent squares, cosecant pairs, I mean, are exactly the same. That includes, like you say they're exactly the same in the setup, you just replace every tangent with cotangent and secant with cosecant.
And put the minus sign at the answer.
Okay.
So literally the previous problem, not this one, but the one that we did up there with the tangent to the fourth. You do the cotangent to the fourth, you are going to get answer to be the same in terms of cotangent and cosecant. It's going to be the same thing. So we're going to take a short break, then we're going to restart the stream for 7.4 trigonometric substitution, because we didn't do enough trig. Now we're going to do trig substitution. Oops.